I am Suresh Kumar, NEET Physics, AGASTHIYA NEET Academy. Today we are going to learn about Unit 7, System of Particle and Rotational Motion. First we are going to discuss moment of inertia. Inertia of rotational motion is called moment of inertia. Okay, moment of inertia is the property of an object by virtue of which it opposes any change in its state of rotation about an axis. Moment of inertia denoted by letter I, so I is called moment of inertia. The moment of inertia is also defined as product of mass and the square of the perpendicular distance. Okay, that is also definition of moment of inertia. Next we will see how to find out moment of inertia about system of particle. One system contains many masses. Okay, now I have to consider only three masses, that is M1, M2 and M3. Here R1, R2, R3, this is the distance means perpendicular distance from the axis. Okay, now I am going to write first particle of mass, that is I equal to M1, that is the distance is called R1, that is R1 square. Now second mass M2, the distance R2 square. Then third mass M3, the distance means perpendicular distance, that is R3 square. Okay, here M1 plus M2 plus M3, this is the addition of mass. Simply we can write summation M. Summation M means addition of all the masses. Okay, that is I equal to summation M R square. This is the moment of inertia of the system of particle. Okay, next we will see moment of inertia depends on three things. Okay, you remember these three things, your job is done. So what is the three things? Number one, position of axis of rotation. Now let me give one example. So I will give long object. Okay, if I rotate about the center, but okay, now I am going to rotate about its center. So it is some rotation inertia. Okay, now I am going to rotate about one end of this object. Okay, this end going this way. This is going big circle. Okay, this end going that side. Okay, so where I am rotated, that is the matter. Only axis of rotation is the matter. Okay, that is the first point, position of axis of rotation. Then second point, mass of the body. Second point, mass of the body. There is a bucket. Okay, look at the picture. There is a bucket. There is no sand filling. Okay, I try to rotate. Obviously, it has some rotation inertia. Okay, imagine. Now I feel sand in it. So now I am going to rotate. Okay, it is very difficult to rotate because mass of the body. Then third one, mass distribution of the body. What is the meaning? Mass distribution of the body. Okay, let me give an example. Okay, now I am holding dumbbell. Now I am holding dumbbell. Okay, like this position. Okay, so I am going to rotate. I'm going to rotate like this. Okay, this is the case 1. Second case, the mass is going far away. The mass is going far away. So now I'm going to rotate. Okay, it has moving big circle. It has moving big circle. This is the case 2. Think about it. Think about it. These 2 cases. First case, holding dumbbell this position. So I'm going to rotate. It is easily rotated. Okay, the mass is, this mass is going far away. So now I'm going to rotate about big circle. Think about it, these 2 cases. So only distribution of mass is changed. So axis does not change, mass does not change. So only distribution of mass is changed. That is the third one, mass distribution of the body. Okay, next, moment of inertia does not depend on number 1, angular velocity. Angular velocity omega equal to v by r. Does not depend velocity and distance. Okay. Then second one, angular acceleration alpha equal to d theta by dt. Angular displacement then time. Then third one, torque, that is denoted by letter tau equal to f into d, that is does not depend force, distance and torque. Okay, then fourth one, angular momentum. Angular momentum L equal to dp by dt. These 4 things does not depend on moment of inertia. Okay, now what is the SI unit of moment of inertia? Okay, what is the formula of moment of inertia? That is I equal to m r square. This is the formula of moment of inertia. Okay, so what is the unit of mass? That is kilogram. What is the unit of distance? Meter square. Of the unit of moment of inertia equal to kilogram meter square. Okay, in series system, kilogram is called gram, meter square is called centimeter square. This is the unit of moment of inertia in CGS system. Okay, so what is the dimension of moment of inertia? So dimension of kilogram, that is capital M. Dimension of length, that is L. Square means we can write square. Okay, there is no time, so we can write T now. That is the dimension of moment of inertia. Okay, distance of the mass increases. Distance of the mass increases from the rotational axis. Moment of inertia is increased. Now, so I am holding dumbbell means dumbbell in this position, axis same, mass same. So the mass is going far away. So mass is going far away. Moment of inertia will increase. Mass is going in this position. Moment of inertia is decrease. Mass is going far away. Moment of inertia is increase. Okay, keep it in your mind. Okay, so next we will see calculate moment of inertia of the given particle system. Given particle system about A to B. So this is the first mass M1, M2, M3, M4. So this is the distance, that is R1, R2, R3, then R4. Okay, how to find out moment of inertia in given situation? That is moment of inertia I equal to first mass 1, that is m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. Okay, now what is m1? That is 1 into what is distance r1? That is 1 square plus what is mass 2? That is 2. What is distance? 2 square plus what is m3? 3 3 into 3 the whole square. Then m4, that is 4. What is distance? That is 4 square. Now 1 plus 2 2s are 4, 4 2s are 8, plus 3 3s are 9, 9 3s are 27. So 4 4s are 16, 16 4s are 64. Simply we can write E equal to 100 kilogram meter square. This is the moment of inertia in given situation. Okay. So next we will see 3-point mass. 3-point mass. Let's solve 3-point masses. That is M1, M2, M3 are placed in triangle of ABC. Triangle of ABC. AB is the distance, that is 0.4 meter. Then AC is 0.5 meter. BC is 0.3 meter. Calculate the moment of inertia of the system about an axis passing through AB. Passing through AB in this plane of triangle. Okay. Now, moment of inertia, that is I equal to m1 r1 square plus m2 r2 square plus m3 r3 square. Okay. Now, what is the first mass? That is 4. And what is the distance? This is r1. This is r2. This is r3. Okay. Now, axis only passing through AB. AB level axis pass agudu. Okay, this is the axis. This is the axis. Here, these two masses, there is no perpendicular distance. These two masses, it has no perpendicular distance. Okay. So that is M1 is 4. There is no distance. That is 0 square. Okay. Plus M2 3. Okay, there is no perpendicular distance about this axis. Axis only passing through AB. AB means there is no perpendicular distance. Okay, this mass only going like this. Okay. Now second mass, there is no perpendicular distance. That is also 0 square. Then third mass, that is 2. Here it has perpendicular distance. That is 0.3 the whole square. Now I equal to 0 plus 0, that is 2 into 0.3 the whole square, that is 0.9. That is I equal to 0.18 kilogram meter square. That is the moment of inertia about given situation. Okay, now I am asking one more question based on this question. Okay, now axis passing through A, axis passing through A and in the plane of triangle. Okay, now I am asking one more question based on this question. Moment of inertia about an axis passing through A. Passing through is not AB. It's not AB. Only passing through A. In the plane of triangle. Okay. Then how to solve? Okay. So axis only passing through A. Okay. Axis only passing through A only. Okay. Now this is the same formula. Now I equal to, what is M1? M1, that is 4. There is no, this mass there is no perpendicular distance, that is 0 square. Plus second mass 3. Okay. Here perpendicular distance is there. Axis only passing through A. Here this is the perpendicular distance. Okay. That is 0.4 the whole square. Then third mass 2. Here perpendicular distance is there. Okay, this is the axis, this is the perpendicular distance is there. That is 0.5 the whole square. Now simplify above terms, that is 0 plus 3 into 0.4 the whole square, that is 0.16 plus, that is 2 0.25 Okay, simply we can write, okay, that is 0.1848 plus, okay, that is 0.50, okay, 0.50. Now finally we can get 0.48 plus 0.50, that is 0.98 kilogram meter square. Okay, that is how you think about it. First one, moment of inertia about passing through AB. This is the axis. Okay, this is the axis. Okay, think about it. Now first case, moment of inertia passing through AB. There is no perpendicular distance between this mass and that mass. Okay, in second case, the axis passing through A only. Axis passing through A only. There is no perpendicular distance mass M1. Okay, so there is perpendicular distance B and C. Okay, the perpendicular distance is 0.4. This axis perpendicular distance is 0.5. So finally we can get I equal to 0.98 kilogram meter square. Okay, this is the case 2. Case 2. Okay, only passing through A, the plane of triangle. Okay, next we will see moment of inertia for continuous mass distribution. Okay, continuous mass distribution. It has consider big mass of system. Okay, then how to find out moment of inertia about this whole mass? Okay, first of all, we have to choose appropriate element of mass. Okay, now this whole object divided into small terms. Okay, the small terms divided into small portion. Okay, now I have to find out one small portion. This is small portion. The small portion mass dm. The distance is called what? This r. Okay, so I have to find out a small mass of moment of inertia. After that, integrate over these masses. Okay, so r square dm. Now the small portion of mass, that is small moment of inertia, di equal to dm into r square. Okay, small mass of appropriate element, that is dm, that as moment of inertia di equal to dm into r square. Okay, now I am going to calculate whole body. Okay, only integrate over, that is integral of di equal to integral of dm into r square.